Welcome to a read along with Dr. Powell in the book Discrete Perspectives in Mathematics. This is subsection 6.2.2. So now we're going to be visualizing volumes by sliding. So if we have a 3 by 3 matrix, that actually gives us the determinant can be thought of as an oriented volume, either positive or negative volume. Kind of the idea is instead of having a base vector, we have like a base parallelogram, and then we have one vector coming off of it. Now, if the vector is above it in some way, it'll be like a depending on our orientation, how we're looking at a parallelogram. If there's an above and a below, if we're above it, then we consider this to be a positive volume. If the vector kind of goes below it, then we consider it to be a negative volume. Now we can tackle this the same way that we did before for the 2 by 2 case. We take this vector v, and we notice that actually this volume function, after we've picked our base and we can and fixing that base, and then we have this v coming off of it, actually preserves addition. So addition is preserved. So addition before the vectors right here will actually end up being addition of volumes, and with positives and negatives and everything, it works great. So we kind of proceed the same way. We take our initial vector v, and suppose that our vector v coming from a base, suppose this is our base. So in columns 1, 3, 2, and 2, 1, 4, make a base parallelogram. And order is actually very important for determinants, how we've ordered things. So let's suppose we've ordered our base vectors this way, first this one, then that one, where the first was just as we were before thinking, when we were ordering things like with our base first and then the other vector, we still have to do that even when we go into the base itself. It has an ordering. So we have the base, let's order it this way. And suppose we have our vector coming off right here as negative 2, 3, 1. We can break this into an addition problem, negative 2, 0, 0, 0, 3, 0, 0, 0, 1 in a very basic way. Okay, and then we can slide. Let's think about how we slide here. So here's our base, right? And here's our vector coming off of it. So what we can do with this vector coming off it in the base is that we can actually slide one part or another, the base or this vector or any other vector in here, as long as we just use the rule or the idea of sliding, that we just take a multiple of one vector that we're considering and add it to the others. So let's just take this vector that comes off and take multiples of it to add to this. Now we can do this in such a way, like we can add negative half times this to this first guy, and then we can do a different multiple even. So after we've slid that way, then we can slide in the other direction by taking a different multiple of this and adding it to this guy. And in such a way, sliding in this direction and that direction, we can zero this out. Basically, take multiples of this written as a column and add it to here and here, and we end up zeroing this out right here. So we what we've done is we've made one of our coordinates, in fact here it's our x coordinate, just 0. We've kind of slid into position. Now we have this vector coming off of this base. This base lives in the YZ YZ plane, and this is an x coordinate. So naturally you could think, well, just take this value, this negative 2, and multiply it to the area given right here. Okay, so that's and now this area is going to be in the YZ plane, and we've talked about how to find the area of something in here. If we just picture it in the YZ plane, this 3, 1, so this like 3, 2, 1, 4. One issue arises though, is this volume that we're getting by having slid over here in that plane over there times this, is that going to be a positive or a negative volume? I mean, and is our viewpoint of this particular area going to be a positive or negative area? It's all about viewpoint. So we imagine that we're kind of looking at everything from the first octant in three space, where we've ordered things in a particular way, and then looking down at everything, sometimes the ordering here actually represents an ordering that happens on the other side of what we see. And if it is, then it would be considered a negative area being on the other side versus the side that's forefront that we're looking at. So in order to determine that, this is what we do. You kind of think, okay, right now we're in YZ over here, but let's kind of, how many different like flips or reflections do we have to do to actually be looking at this in the XY plane where we're used to seeing things? Well, if you like every time you switch two things around, that's like that's changing your orientation, like going to the other side of something. If you do it an even number of times, it's going to be represent a positive area when you switch your viewpoint to the XY plane. Like if you put these in the YZ places into the slots that represent X and Y, then let's see, there's two switches involved. You can switch 0 and Y, and then you switch 0 and Z right here, and you get there's two switches, which means it remains the same positive oriented area. So really it amounts to just, so when we find the area over here and multiply it to the -2 here in the volume calculation, this area is going to represent a positive area as we would normally think in the XY plane. So we can compute this area right here using the same technique that we saw before. You just take this diagonal minus that diagonal. So 3 times 4 minus 1 times 2, multiply that by the -2, you get -20. Okay, so we were successful at saying -2 times, basically what we did is we took -2 times the determinant of this lower part right here. Okay, so that's where we're off. Now we need to do the other parts. Remember that 3 was the next guy coming from our initial vector, -2, 3, 1. Let's look at 3. So this component right here, 0, 3, 0. And by sliding in the same way, we can zero out the middle guy. And now we're looking at this determinant, 1, 2, 2, 4, except we have to think like, and we're in the, actually the ZX plane or the XZ plane, but our orientation, in fact, that comment was pretty telling, because do we call it the ZX plane or the XZ plane? That has to do with orientation. In order to get this looking normal, we have to do a switch. In fact, it's just one switch. We just interchange these, but every switch changes the orientation, which means this is actually a negative area we're considering that we multiply to this. So from our standard viewpoint. So we pretend like it's 1, 2, 2, 4. We compute that area, but then we need to change its sign since we're kind of looking at it from a different orientation. And then we multiply it by that 3, which came from that component 0, 3, 0. Okay. And we multiply that to get the volume coming from this part to be -5. Okay. Let's see. Oh, let's see. The volume from, oh, I see. So 3 times this, following the same logic. Okay. Let's take a look at where we're at so far here. Make sure we're in the right place. So we have -2, 0, 0, 0, 3, 0. So I was looking at this one where we zeroed out the middle guy. We have 1, 2, 2, 4. We compute that. We have 3 times that. Okay, the last piece. Okay, and that piece ends up giving you 0. Oh, I see. Okay, I skipped a line here. So this times this gives us 0. Now, right here, let's see what's happening over the next. This is the last part where we have a 1. So using the exact same logic, let's take a look at what we're doing up here. We have 1. Okay, so this 1, 0, 0, 1. So this 1 is multiplied to, we can zero out this bottom. Now notice that this is in the right orientation up here for just considering it as normal, 1, 3, 2, 1. And we can just find the determinant as usual. So 1 minus 6 would be -5, which was what we had in this calculation down here. Okay, so we get all our pieces. We have -5. This one was 0. The middle guy was 0. And then the other one was -20. Now, if we add those together, because we can add the volumes together, and it's the same as adding the vectors before, and we get negative 25. So this is the oriented volume is negative 25 of what we were considering. So we had these vectors right here, 1, 3, 2, 2, 1, 4. And let's see here. Let's look at this. Make sure we got this right. See, 1, 3, 2, 2, 1, 4. All right. So 1, 3, 2, 2, 1, 4. And notice how this is interesting. Notice how we put our base over here on this side. Okay, so we have negative 2, 3, 1. Because the whole time we were just it was just kind of off to the side. But notice if we're using this terminology where we have base first and then vector, realize that our base was actually 2 vectors big, right? This was our base, and then that was our vector coming off of it. Just like in the 2 by 2 case where we had base, then vector, here we have base, then the vector coming off of it. So we just figured out the oriented volume of the vectors in this order. First base, and then the vector coming off of it, using the idea that this idea of vector off of base preserves addition. Thanks for watching.